Welcome back to yet another lesson. Today we're going to go through 5b, which is recursion relations, linear depreciation. Now, depreciation is the financial process whereby an item or asset loses its value over time, generally due to wear and tear. Let's begin by talking about flat rate depreciation. The amount the asset decreases is called depreciation. So that's represented with letter D. For flat rate depreciation, the value decreases with respect to time and is a constant amount. It is calculated as a percentage of the original value. That is so important. It is calculated as a percentage of the original value. The rate of depreciation is given as R%. So here's our recursion relation. So in general, we've got our initial starting value, and then our next term is given by the current term minus by D. The way that we figure out D is we figure out the percentage that it's losing of the original. That will make more sense once we dive into an example here. But again, this is very important for you to look back on. All right, let's now jump into example 1 and see this in action. So an office purchased new furniture for $13,800. The flat rate of depreciation is 10% per annum. Notice that the key things I've highlighted here. I've highlighted, grab my pen, my initial value, that I'm dealing with a flat rate depreciation, and the fact that it's decreasing by 10% per annum. Now it says model this flat rate depreciation using a recursion relation in the form of this. The most important thing here to recognize is that if we want to figure out what D is, so D here, we're trying to figure that out. We're going to say that this here is my R value. So I'm going to take 10 over 100 and times it by V of 0. Now V of 0 is what it originally was worth, 13,800. So all I'm doing here is figuring out what is 10% of the original cost. And when I come to my calculator and I figure that out, I go 10 over 100, then I times it by 13,800. I'm going to end up with 13,800. So that is how much 10% of the original is. Now remember, each year, what I'm going to do is I'm going to lose that much of the value. So I'm going to begin by saying it's originally worth 13,800. But then each year I am losing 10% of that original cost, meaning V of N is going to be subtracted by 1380. That is what is happening here. Really important that you recognize that flat rate depreciation means you're losing the percentage of the original amount. So every year I'm losing 10% of that original cost. All right, let's now see this in action by doing this. Use the model to determine the value of the office furniture after 3 years. All right, so we know that when we buy the office furniture, it's going to be worth 13, and I might actually just move this a bit here. We know that it's going to be 13,800. Then at the end of the first year, Okay, at the end of the first year, we've got V1. And I figure out V1 by going 13,800 minus 1380, because that is the cost. That is 10% of the original, which leaves me with 12,420. At the end of the second year, the end of the second year is going to be V2. I take this value right here, 12,420, and I again subtract 10% of the original. That does not change. 11040. Then I want to figure out the end of the third year. That's going to be V of 3. That's going to be 11040, which is 1380, which is going to end up being 9660. Therefore, I might even do this in another color just to show you that it's important. I'm giving a little statement now. Therefore, after 3 years, it is worth $9,660.00. That is what's happening there. The last part here is saying, when will the value of the office furniture depreciate to 0? A couple of different ways we could go about this. We could say, all right, we know that the original cost of the office furniture was 13,800. So notice here I'm using my CAS. Then I'm going to subtract 1380 from that each year. So that's at the end of my first year, second year, third year, fourth year, fifth year, sixth year, seventh year, eighth year, ninth year, 10th year. After 10 years, it hits zero. So it's going to take 10 years to hit zero. Now, there are going to be other ways for us to answer these types of questions when they're asking how long will it take for it to hit zero or another price. But for now, I'll just show you this way because it does work. But you notice how, imagine if we had to keep on doing that for, 100 times. Maybe there's probably a better way to do it. Nevertheless, it's good for you to see it like that. All right, there you go, people. That is a bit of an introduction. Let's now keep soldiering on.